All right, welcome everybody. This is 2.3, the first part of 2.3. So what I'm going to cover in this video is how to complete the square, how to do the complete the square process on a quadratic equation and on a quadratic function, okay? So this will be the first part of 2.3. It'll be a separate video, and then I'll make a new 2.3 because the 2.3 I already have on YouTube doesn't really match the homework on my math lab. So there will be a 2.3, two parts to 2.3. So for the first part, let's just go over completing the square process and what type of math magic we are using, right? Okay. So completing the square on an equation. To solve a quadratic equation, which is of the form ax squared plus bx plus c equal to 0, we can complete the square. Use a process called completing the square. To solve it by completing the square, the leading term, so the leading term is always the term with the highest power. So ax squared is the leading term. So in order to complete the square, the leading term's coefficient, and here a is the coefficient, must be 1. So to complete the square, the leading coefficient has to always be 1. Okay. If the leading term is not 1, then we must factor it out to make it 1. Okay. And once you put the quadratic equation into its proper form, meaning you keep all the x variables on one side and you put all the other terms on the right side, we should have something of this form: x squared plus bx equal to c, where we see now that the leading coefficient is now 1 because all it is just x squared. So the leading coefficient is 1. Okay, once we have it in that perfect form, then we can do the process. We can do the complete the square process, which means we're going to take half of the middle term's coefficient. The middle term is bx, and what we're going to do is just take half of its coefficient. The coefficient is b, and we're going to take half of it and square it, okay? We're going to take half of b and square it. Okay, after we take half of b and square it, then what we do with that number is add it to both sides of the equation. We take the number that we got from the completing the square process and we add it to both sides of the equation. Okay, after you add that number to both sides of the equation, the left side of the equation becomes a perfect square. This part becomes a perfect square, which means you can factor it. So you will always factor the left side, or whatever side you have all this on, and then the right side you will simplify. And once we get there, once we factor, once we simplify, we will then solve for x by using the square root method. Okay. And once we solve for x, our x values shall be written in the format of fancy brace x value 1, comma, x value 2, close fancy brace. Okay, because that's how we can denote or notate a set of solutions. All right, let's try it out. All those words above, right? All we have to do is follow the steps, okay? Okay. So, example 1. we have x squared minus 6x plus 5 equal to 0. Solve for x by completing the square. Okay, solve for x by completing the square. Well, first thing we notice is that, whoops, not there. The coefficient of this x squared happens to be 1, which means we have one of the pieces done already, one of the steps done. One of the first steps is to say, is that coefficient 1? And if it is, we can move on to the next step. So, let me see. There we go. All right, so I'll say step A, we have x squared minus 6x plus 5 equal to 0. Our coefficient, A, is 1. The coefficient is 1, which is perfect. Okay, which means we can move on to step B, which means keep all your x values on the left side, move everything else to the right side. So step B, we're going to have x squared minus 6x equal to negative 5. Okay, we now have the perfect setup. This looks like x squared plus bx equal to c. We now have the perfect form, which means the next step is we can start the completing the square process. C, we are going to take half of the middle term's coefficient. So I'm going to say CTS. Complete the square. We're going to say b over 2 squared, and negative 6 is our b value. So that's what we will plug in for b. This will become negative 6 over 2 squared, which gives me negative 3 squared, which will give me 9. Okay. So we have just done the completing the square process. We have taken half of the middle term's coefficient. We have squared it. Now the next step is to take this number 9 and add it to both sides. So D, we're going to have x squared minus 6x plus 9 equal to negative 5 plus 9. So we made it to this step. Okay, so we add 9 to both sides of the equation, and now step E, we will now factor the left side. All right, x squared minus 6x plus 9 is going to factor to, if we look at the signs, minus plus means x minus a number times x minus a number. What number goes in these parentheses? what are two factors of 9 that can make -6? Well, I have a lovely little trick for you to make this easier. Go back to the third step, step C. What number did we square at the very end? We squared -3. And there's a nice little trick here. The number that goes in the parentheses is also going to be -3. All right. And then this will be equal to -5 plus 9, which gives us 4. All right. So that was factor. This was simplify. So step 4 was factor and simplify. Okay, well, the last step is to solve. So F, we need to clean up the left side. X minus 3 times x minus 3 means I have x minus 3 squared equal to 4. And now we're going to solve for x. And the way we solve for x is we use the square root method. Square root, and I will get x minus 3 is equal to plus or minus 2. So remember, when we're solving for a variable, if we square root both sides, the number on the right should be plus or minus always. You should always have two answers on the right side, a plus, a positive, and a negative, plus or minus 2. Okay, so we use the square root method, we solve for x. All you have to do is add that 3 over to the right, and we will get x equals positive or negative 2 plus 3. And now, keep going. We're going to have the first answer, which is going to be x equals positive 2 plus 3, which gives us 5. The second answer, negative 2 plus 3 gives me 1. Here are the answers. There's our x values. And which I said to notate our answers as fancy brace 5, 1. Okay. That is how you complete the square on an equation. And we'll try it again on the next example. I'll say solve for x by square root method. Okay, let's do it again. A, we are given 9x squared plus 18x equal to 7. Okay, well, for this one, it seems that the x's are already on the left side, which is perfect, and the constants, the numbers, are on the right side, which this is in a good form already. The only thing we have to worry about is that the leading coefficient is actually 9. Cannot write today. Let's go. The leading coefficient is 9. So we need, in order to complete the square, we need that leading coefficient to become 1. So what we're going to do is factor out the 9. So we'll probably have more steps here. So I'll say B, I'll factor out the 9, which means I'll get 9 times x squared plus 2x equal to 7. I'm going to say factor out 9. Okay, and then after we factor out the 9, I'm going to get rid of it by dividing it out. So C, we're going to say 9 over x squared plus 2x equal to 7. And we're going to divide by 9, divide by 9. Okay. And what happens is that these 9s will cancel, and we will be left with x squared plus 2x equal to, what is up with my pen? It is not wanting to write. 7/9. Okay. So I'll list our steps here. I'll say and then down here, we have the form that we want, so we can continue to complete the square. We have x squared plus bx equal to c, which means we can move on to step D and complete the square. Complete the square, all right? Remember that it's b over 2 squared, and our b value is at 2. It's the middle term's coefficient. So we'll get 2 over 2 squared, which gives me 1 squared, which is 1. Okay, and now we're going to take that 1 and add it to both sides. So E, x squared plus 2x plus 1 equal to 7/9 plus 1. Okay, and then F, you know what comes next? We will factor. So again, factor, and this is plus plus, which means you'll get x plus a number, x plus a number, and again, the number that goes in there is the number that we squared. That number is 1. It's a nice little trick that comes in handy, especially if these numbers are ugly, which will probably get ugly numbers. So you'll get 1 and 1, and then equal to, and then over here was simplified. So I'll write this out. You'll get 7/9 plus 1. Okay, so what we need to do is combine these two numbers. You're going to put 1 over 1. You'll make it into a fraction and multiply by the common denominator of 9. This becomes 7/9 plus 9/9, which gives me 16/9. Okay. Now, sum it up. I just have room over here. E, F, G is my next one. So we'll move up here. I have x plus 1 squared equal to 16/9. Okay. Next is, oh, this is G, right? Solve by the square root method. So we'll say square root. I'll do different colors since red's right there. Square root, and we should get x plus 1 equal to, don't forget, the plus or minus. Okay, and what is the square root of 16? That's 4. What is the square root of 9? That is 3. Now move the 1 over, subtract the 1 over, and x equals positive plus or minus 4/3 minus 1. Okay, we now have to solve it more, which means we're going to go the plus route, which will give me, actually, don't forget the x. X equals positive 4/3 minus 1. Put 1 over 1, multiply by the common denominator of 3. We get 4/3 minus 3/3, which gives me 1/3. And then go the minus route. X is negative 4/3 minus 1. Same thing from above. We know that 1 can change into 3/3 if we multiply by the common denominator. So this becomes negative 4/3 minus 3/3, which gives me negative 7/3. And these are the x values. You get fancy brace 1/3, comma, negative 7/3. All right. And that is how you complete the square on an equation. So equations we solve. On equations, we will solve for x, okay? All right. What's next? So that was on an equation. Next is completing the square on a function, which is gonna be a little different. So only a slight step in the process has changed. So our goal is, if we're given a function this time, not an equation, if we're given a function, so here's my quadratic function, our job is to turn it into a different looking function. And this function is called the vertex form of a quadratic function. So we need to go from standard to vertex, okay? So this is a standard quadratic function, and we need to change it into the vertex form. Now, why are we doing this? It's because it's going to make graphing quadratic functions, because we've been learning about functions. This section is about quadratic functions. It's going to make quadratic functions, graphing them, and finding the pieces, the characteristics of them, a lot easier. So, knowing how to complete the square on this is important. All right. All right. So, like I said, this will be a little different than the completing the square on an equation. Some methods remain the same. One thing that remains the same is the leading coefficient must still be 1. If it's not, we will factor to make it so, like we did on the last example. And this time, instead of adding it to both sides, because we don't have two sides, we only have one side, that's the right side, we will now add it and subtract it on the same side. So after we take half of the middle term and square it, we will add it and subtract it on the same line. Same line, same side. That's mainly the only difference here. Okay. So after you do that, the first 3 terms will be factorable, just like on the ones above. And the last 2 terms, you will simplify, just like the problems above. So everything you see here. And once we do that, it will put our quadratic function from standard form into this lovely vertex form. Ooh. All right, let's try it out. Okay. So complete the square and find the vertex form of the quadratic function. F of x equals negative x squared plus 8x minus 3. So I'll write it here. A f of x equals negative x squared plus 8x minus 63. Okay. So this is step A, and what we notice is that the leading coefficient is -1. And in order to complete the square, the leading coefficient must be +1. So we have to get rid of that -1. Okay, so here's where it's going to get a little tricky. So step B, I'll have f of x equals, and what I'm going to do is factor the -1 out, but I only want to factor the negative out of the x terms only. Yes, you can do it. So let me just rewrite it real fast. -x squared plus 8x minus 63. So for this one, we're going to group these two terms together, which is allowed, and factor the negative only out of these two terms. Which will give me f of x equals -1. We have taken it out. We have factored it out. Times +x squared minus 8x minus 63. Okay. We've done nothing wrong. We've taken a -1 out. If I want to go back to the original equation, just distribute that -1 back in, and we're back at the original equation. That's just to make sure we haven't done anything wrong. Okay. So now, focus on the inside function. Is this in the perfect form to complete the square? And the answer is yes, because the leading coefficient is now 1. The leading coefficient is now 1. Which means we can now complete the square. All right. I think that's enough for the process, right? I don't have to write anything out to the side. I said factor out -1, and now our leading coefficient is 1, which means we can move on to step C and say complete the square. Okay, so remember it's still b over 2 squared. Our b value is now -8. Our b value is -8. You get -8 over 2 squared. Simplify. -4 squared gives me 16. Okay. Here is the number we get from completing the square. And now, we got room. Yeah, I can go to step D here. So what I'm going to do now is add that number and subtract that number on the same line. Okay. So you're going to get -1 times x squared minus 8x plus 16 minus 16 minus 63. So I have now taken this number and added and subtracted it on the same line. All right. Now, more tricky stuff, right? These ones are not as fun as the equations. They are tricky, okay? So let's go to step E. Okay. So what I'm gonna do now, well, let's look back at D, is I'm gonna combine these three terms together, okay? I'm gonna put these terms together because this is the part that we can factor. So I'm gonna say factor, and this guy, I'm gonna say isolate, or leave alone, okay? Leave it alone. So here's what we're gonna end up with. F of x equals -1, and I'm gonna put a bracket here just to be neat. We're gonna factor x squared minus 8x plus 16. So here you see down there, it's minus plus, which means you'll get x minus a number, x minus a number, minus the 16 that's already there. And then, of course, the 63 that's waiting outside for us. The 63 that's waiting. Okay, we've seen this trick before. What number goes in the parentheses? That -4. That's what we squared, right? So you'll get -4, -4. Okay, perfect. Which means, let's clean this up. -1. Keeping the bracket there for neatness. X minus 4 times x minus 4 is x minus 4 squared minus 16 minus 63. Okay, what comes next is distribute the -1. So we're going to distribute the -1. This -1 will distribute here and here. Okay, there and there. So what we end up with is f of x equals negative, or -1 times x minus 4 squared plus 16 minus 63. And we're almost done. Now, combine these like terms, simplify. And once we simplify that, we are done. So our final answer is going to be f of x equals -x minus 4 squared minus, what's 16 minus 63? Is that 47? Yes. And we now have taken the standard form of a quadratic function and changed it in to vertex form for a quadratic function, all by the completing the square process. Awful, I know, but we're gonna need it for this section. Okay. All right, this is I guess I could have put my 16s in red down here, right? Let me do that. Yeah, that's it. Take it in. It's a process for sure. Okay, one more completing the square problem for this video. And then more completing the square for the next video. But we're gonna do it for graphing, okay? This is just to get the process out of the way so you're not staring at the next video like, what is going on? Even though you're probably staring at this video like, what is going on? So hopefully can knock this process out. Okay, 4. Complete the square and find the vertex form with a quadratic function f of x equals x squared minus 4x plus 17. Okay. So here we go. Let me write the function over here. A f of x is x squared minus 4x plus 17. Okay, perfect. Okay, well, lucky us. The leading coefficient is a 1. Why didn't we start off with this one? Okay, the leading coefficient is 1, which means we are now good to go. We can actually complete the square, right? We can complete the square on this because this is in the perfect form. We need it for a quadratic function. Okay, so since that leading coefficient is 1, we don't have to factor anything out, which means we can move to step B, which is complete the square, and it's b over 2 squared, where your b value is -4. You will get -4 over 2 squared, which gives me -2 squared, which gives me 4. All right, now again, what do we do with that number? We add it and we subtract it on the same line. Okay, so C, you'll get f of x equal to, and I'm going to put this in parentheses just to make it relate to the one above it. You're going to have parentheses x squared minus 4x plus 4 minus 4. Close parentheses. And who's waiting outside? The 17. Okay, and for the next step, once again, factor these three terms because that's the perfect square trinomial. That is us completing the square. And isolate this term, the -4. Leave it alone. Okay. So D, you'll get f of x equal to, and again, bracket to be neat. Just to be neat, we don't need it there. We're factoring x squared minus 4x plus 4. So minus plus means x minus a number, x minus a number, minus the 4 that's there already. And again, what number goes in these parentheses? That is going to be the -2. So you'll have -2 minus 2. And don't forget about the 17. Okay, let's clean up. I can now drop the brackets. I didn't need them there. I needed the brackets for the last one. I do not need the brackets for this one because we are not distributing anything. So if there was a number here, we would be distributing. There's no number out there, so there's no need to distribute, which means I can now write E as f of x equals x minus 2 squared minus 4 plus 17. Simplify. And we get our final answer. Where do I have room, right? F. I'll just say, I'll say our final answer is f of x equals x minus 2 squared minus, actually not minus, -4 plus 17 is a positive 13. And there is our vertex form by, once again, completing the square on a function. Okay, and that is the completing the square process. Definitely number 4 was easier than number 3. But this is how we do it on a function. And the 2 above is how we do it on an equation. What's the main difference? Well, one of the big differences, one of them's an equation, one of them's a function. The other big difference is equations you will solve. Functions you will simplify. Okay. So these are on your 2.3 notes. I'm stopping here for now. And we will get into graphing quadratic functions on the next video. For now, we knock out completing the square just to get it out of the way. And that's it.